Today we're going to talk about horizontal and vertical lines. So you should be on page 25 and make sure you write your name up here, please. So here's Mr. Slope guy. Mr. Slope has eyebrows. He has a positive eyebrow. So this is a positive slope. From left to right, it's going up. And he has that negative eyebrow. So from left to right, it's going down. So that's negative slope. And then we have his nose. Well, we have a vertical line representing his nose, and then the bottom of his nose is a big U for undefined. So the line up and down, and then the U for undefined. Well, because the slope of a vertical line is undefined. So here's your vertical line, vertical. And now we have our horizontal line. Horizontal line, like the horizon, goes left and right. And that has a slope of 0. How am I going to remember that? You see these dimples here? Cute, aren't they? Zeros. So vertical, up and down, undefined. The 0 is his mouth, because mouths have dimples. Well, some do. Mine do. Okay, next, let's get back to this then. So, horizontal line, slope of 0. We'll put the dimples in there so we can help ourselves. Here's the nose, undefined. And then we have our positive slope. And we had the negative slope. Okay, exercise 1. The line y equals 3 is graphed on the grid at the right. So here's the graph of the line. I highlighted it, and the name of it is y equals 3. Why? Because it goes through y equals 3. There's the point, y equals 3. And by the way, there's a point here, and the y value is 3. It's 3 above the x-axis, and here it's 3 above the x-axis. So the line y equals 3 simply, it means a line that is 3 units above the x-axis. Okay, so let's do this. Y equals 5. Well, if we follow the same method here, let's go 1, 2, 3, 4, 5. And while we're at it, let's hit another spot here. 5 above the x-axis, 5 above the x-axis. We can take our straight edge, make the line. We need to have arrows at either end. And the name is y equals 5 because it is 5 above the x-axis. Goes through the y at 5. Okay. Here's the next one, y equals negative 2. Y equals negative 2, I guess that should be 2 below the x-axis. So we're going to count down, 1, 2, below the x-axis. And make a point there with the pen, not the highlighter. And if we go anywhere along the x-axis and go 2 below, we are going to come up with the line y equals negative 2. Make sure you write your arrows. And that's y equals negative 2. And take notice, this y-intercept here is negative 2. The y-intercept here is 3, and the y-intercept here is 5. Okay, exercise number 2. Which of the following represents the equation of the graph shown at the right? Well, here's the graph shown at the right. Let me highlight that. Why don't we all highlight? I like to see that highlighting in your notes. It makes me know that you're actually doing it. Makes me happy. Okay, so we highlight the line just so we know what the deal is here. And now we can see easily that line is going through y equals -4. 1, 2, 3, 4. It is perpendicular to the y-axis. It's parallel to the x-axis. And -4's are b. Look at that. So all we need to do is find y equals b. And that's it. Okay, so let's just remember this. When we have a horizontal line, it's just y equals whatever the y-intercept is. That's going to be very helpful as we go through this. All right, exercise 3. The line x equals 2. X equals 2 is drawn here, is graphed here. There, highlight. Graph and label lines x equals 4 and x equals -3. All right, so let's just take a look here. X equals 2. Well, x equals 2 goes through the x-axis at 2. So you're simply going to plot a point at x equals 2 and graph the line. So when we look at x equals 4, we're going to do the same thing. X-axis, 1, 2, 3, 4, plot the point. I keep trying to get my pen. Aha, I see. Okay, plot the point. Use your straight edge and draw a line right through it. And then you can just put your arrows in and label it. Now in this case, it's going through the x-axis at 4, so we're going to write x equals 4. That is the name of the line. Okay, and the next one is x equals -3. I go left 3, 1, 2, 3. I put a little point there for reference. I use my straight edge, and I'm going to go right through x equals 3, perpendicular to the x-axis, but at the same time, it's parallel to the y-axis. Okay. Make sure I label it and have arrows. Okay, so that one's done. That's done. And now we can go to part B. State the coordinates of A and B, point A and point B on line x equals 2. All right, so here we are. There's point B. Here's point A. And don't forget, when we're naming points, we start at the origin. We're going to go over 2, so right 2 and down 1, 2, 3, 4, 5, 6. So that's going to be, the point A is going to be 2, -6. And then we have point B at over 2, 1, 2, up 3. Okay, so we have an x and a y coordinate for each one. X, y. Okay, so now C says, if it exists, find the slope of the line connecting A and B from above. Well, let's start at A and go to B. I rise 1, 2, 3, 4, 5, 6, 7, 8, 9. I rise 9. And I run. Well, I don't run anywhere. I guess that's 0. Dun, dun, dun. This is not good. 0 cannot be in the denominator, and that's why the slope of a vertical line is undefined. Okay, it all goes back to having a 0 in the denominator of a fraction. So, remember the nose on Mr. Slope? And he had the bottom of his nose, and this was, you know, the long part of his nose. I don't know what that is called. That's undefined. So there's where that undefined comes from. Okay, part D. If it exists, find the y-intercept of the line connecting A and B. So here's A. Let's see where it goes through the y-axis. As I move my pen up, do I ever hit the y-axis? The answer is no. So I can write, there is none. There is no y-intercept. Okay? Why is it not possible to write the equation of a vertical line? It's not possible to write the equation of a vertical line using y equals mx plus b. Well, let's see. What number are we putting in for m? There is no number. That would be undefined. You can't figure anything out with undefined. So it just doesn't work out in this particular case, okay? There is no slope. Well, there is no number, a value for slope. And by the way, there is no y-intercept either. Okay, so I think we're going to move on to the next problem then. Okay, number 4. Graph the following 3 lines and find the area of the triangle enclosed by them. Area formula. Yeah. Okay, so let's just take a look at what we found in the above example though. X equals A, where A is the x-intercept. All this means is, if they give you x equals 5, count over to 5 on the x-axis. 1, 2, 3, 4, 5. And now, that point is going to be called the x-intercept. It's the point where the line goes through the x-axis. We don't hear that name a lot, but pretty easy to understand. Okay, and oops, I'm going to put some arrows at either end to show it's a line, and label it with x equals 5. Okay, y equals -3. Okay, we're back to the y-axis. Y equals -3. Down 3 on the y-axis. And we are going to make a horizontal line because it has to go through the y-axis. And okay, arrows, arrows, y equals -3. Okay, and lastly, oh, look at this. We're back to our old lines again. So this is not going to be horizontal and it's not going to be vertical. This guy is one of our slanty lines that we've been doing all along. So if we determine our m value to be 2 and our b value to be -1, then I know we begin graphing at -1 on the y-axis because this really is just your y-intercept for this particular line. And then we're going to use the slope. It's going to be, the slope is going to be 2 over 1. So we're going to begin at -1 and go up 2 over 1, 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And we're trying to connect this because we're going to get a triangle here, remember. So how about down 2 and over 1? Okay, next we're going to take our straight edge and go back to connecting slanty dots, or the points on a slanted line. Whoa. Let me just fix my line ran away from me. That was weird. Okay, and this guy's going to be here. Okay, so now, what is the formula for finding the area of a triangle? A equals base times height over 2, or some people like area equals 1/2 base times height. Either or. Okay, our base. Well, I think this calls for a highlighter. Woohoo! Our base is this guy down here on the bottom. And our height, use that. Okay, so our base is going to be 1, 2, 3, 4, 5, 6. And our height, oops, I need my pen back, 6. And my height is going to be 1,